Hello friends, let us deal with one important program of an array. To arrange the given numbers or to sort a given set of numbers. We call this as sorting. A sorting program can be to arrange a set of numbers in ascending order or in descending order. There are various techniques which are used to arrange a given set of n numbers. These given set of n numbers can be arranged in ascending or descending, say using a binary search method, using a radix sort method, using a heap sort method, or using a bubble sort method. The most easiest and the one which is convincing is bubble sort method. Let us discuss out this particular bubbling of numbers and sorting these numbers in ascending or descending order. You can try the program with any one, right? So let's try and sort these given set of n numbers. So now, assume that I have 4 numbers. Now let me take 4 numbers for you. I'll say 12, say 7, 4 and say 3 or let me say 13 or have a number say 9 at this particular place. I have 12, 7, 4, 9. My task is to arrange these numbers in ascending order, in the increasing order. Let me play with these numbers. You can try this along with me. You can take a piece of paper, jot out these numbers and do the operations as I say. Or what you can do is at the end of the entire video, you can pause it, understand the entire concepts and do the operations which I say in this entire video on your own. When you try it on your own, at that time you feel much more comfortable. First, watch the entire things carefully, right? Okay, let's start with this operation. In the first stuff, what I'll do is, I'll compare the first number with the remaining numbers of the list. So 12 need to be compared with all the numbers of the array. Since I'm supposed to arrange the numbers in ascending order, what I'll do is, I'll ask, is 12 greater than 7? Yes, it says true. True in the sense, what I'll do is, I'll say 7. 12 comes on the other side. So I'll interchange these two values and then 4 and 9. Now, again, the first number of the array has to be compared with the next number. Is 7 greater than 4? True. True in the sense, what we'll do? Again interchange these two values. So this comes on the top, 12 will be as it is, 7 comes to this particular place and then 9. And the third comparison is 4 with what? The last number. 4, is it greater than 9? No. Keep the number as it is. So I'll say 4, 12, 7, 9. What I did was, I compared the first number with all remaining numbers. Let me write this with index. Assume that the first number is at a of 0, second number is at a of 1, third number is at a of 2. So here a of 0 was compared greater than a of 1. Then a of 0 is greater than a of 2. And finally a of 0 is greater than a of 3. Now with respect to arrays, this is what operation I have done. What are achieved at the end of the first operation? At the end of the first operation, can I say that I had bubbled out the smallest number and placed it at the top? We are just bubbling out. Assume that there are big different size of balls. What we'll do, we'll just blindly go into that particular stuff and keep on sensing those parts and get the smallest of that. If I hold the smallest one, if I feel that the other one is smallest, what I'll do is, I'll throw that and catch the new one. So throw that and catching the new one is nothing but swapping. So first step, compare the first number with all other numbers in the list. So a of 0 greater than 1, a of 0 greater than a of 2, a of 0 greater than a of 3. Let me call this as trip number 1, that is first trip. Now let me start the second trip with the number. So the second trip, the output of the first will be the input. So I'll say 4, 12, 7, 9. So in this case, we'll not touch the first number. We'll take the second number and compare this with the remaining numbers of the list. So 4 is as it is. 12 is it greater than 7? Yes, 12 is greater than 7. So what will do? You will go with this particular swapping operation. 7 comes at this place, 12 comes at this place, 9. So take 7, compare 7 with 9. Is 7 greater than 9? No. No in the sense, keep the number as it is. 4, 7, 12, 9. I have taken the numbers in a worst case, hence probably the operation might require more time. If you take any other set of numbers where the numbers are almost arranged, only one operation need to be done. then in that case probably only in the first operation itself the number might be arranged in ascending order. So we end up this particular second trip. What we achieved at the end of the second trip? We achieved the first two smallest number on the top. So here the comparison was a of 1 with a of 2 and a of 2, sorry, a of 1 with a of 2 and a of 2 with, sorry, again a of 1 is greater than a of 3. 1 was compared with 2, 1 was compared with 3, right? Okay. So let me call this as second trip. And now I'll have the last trip 4, 7, 12, 9. So what to do? First two numbers are not supposed to touch. I have only one possibility. Second last number with the last number. So 12 greater than 9, true. True in the sense 4, 7, 9, 12. What you did? A of 2 is it greater than a of 3? True. This is my third trip. So when the numbers are arranged in a worst manner, we call this as a worst input case. This will consume more time. Assume that all the numbers are already arranged in ascending order except the first two. Probably in the very first cycle itself, you might get the numbers. That is the best input. I have tried it for the worst input. Depending upon the input, you might get sorted these numbers in the second trip or even at the first trip. But in the worst case, I am supposed to design the program always in the worst case. Hence, in the worst case, I'll say that for 4 numbers, I need 3 trips. If this could have been 100 numbers, then probably I could have used 99 trips. Why don't we name these trips? Why don't we say this as trip I? Why don't we say the trips with a variable called as say I? In this case, let's set I as 0. Let's strip I as 1. And the next trip I as 2. So I started with I equals 0, I equals 1 and I equals to 2. So it means that for n numbers, if I name the trips as I will always start with 0 and go till what? N minus 2. True, because for 4 it ends up at 2. So 0 to n minus 2. For n minus 2 there is one more logic. Why n minus 2? Now see here, first number can be compared with remaining numbers. Second number can be compared with remaining numbers. Third number can also be compared with remaining numbers. But this last number second last number can be compared with last number. Can we compare the last number with anyone else? No, not possible. Hence the trips will start with 0 and go till second last number. So if the last number is indexed as n minus 1, the second last number will be always n minus 2. So 0 to n minus 2. Got the idea? Okay. So I will say that trips are from 0 to n minus 2. That is the conclusion which we have done for trips. In every trips, again we have some comparisons. What are these comparisons? Let me identify the comparisons as J. So J is a comparison. So in the first comparison, when I is 0, your comparison started with what? 1, 2, 3. So J starts with 1, ends up at 3. When I was 1, J starts with 2 and ends up at 3. When I is say 2, J starts and ends up at 3. So J equals to 3. Let's finalize the condition for this particular J. If you observe, the index in the last case is always 3 for J. So n is 4 in this case. So it means that J is 3, that is J equals to n minus 1. So in the last value of J is n minus 1, but the first value keeps on changing. When I is 0, J starts with 1. When I is 1, J starts with 2. When I is 2, J starts with 3 and ends up at 3. Which means that J will be always one step ahead of I. Since J is I plus 1 and go till n minus 1. And I will start with 0 and n minus 2. So what we need to do is, we need to summarize these loops. So the loops which I am going to use are I, which is a trip loop, which goes from what to what? 0 to n minus 2. J is a comparison loop. So here J has to be assumed as a comparison loop, and this comparison loop starts with yes, you recognized it properly, I plus 1. J is always one step ahead of I and it ends up at n minus 1. You should always remember these loops for sorting. Anytime when you are going to do a sort, always make sure that you are going to use your 2 loops, one for trip and one for comparisons. Now, as for the example, what were inside what? Where the comparisons inside a trip, or were the trips inside a comparison? If you closely observe the way in which numbers have been shuffled, we find that every trip has got some comparisons. So the comparisons are inside a trip, inside the trips, which means that your J loop is an inner loop for I. It is going to be a nested loop where I is going to be the outer loop and J is going to be the inner loop. So there is one more logic, why n minus 2. First number can be compared with last number, second number can be compared till the last number, third number can be compared till the last number, the second last number can be compared with the last number, but the last number cannot be compared with anyone. So hence I should avoid comparing the last number, I should stop at the second last number. So if the last number has got an index as n minus 1, second last number is n minus 2. J is always one step ahead of I. When I starts with 0, J starts with 1. When I starts with 1, J starts with 2. When I starts with 2, J starts with 3, and so on and so on. So it means that J is always one step ahead of I, and it goes till the last number, hence I plus 1 to n minus 1. So let's see a program on illustrating this particular I and J loop. Now here the program has been written for you for sorting these numbers. As usual, the numbers have been read, the total numbers, and then the input which has been read for these numbers. The numbers which I took were 12, 7, 4, 9. So n is 4, 12, 7, 4, 9. So in this 12, 7, 4, 9, I'll say that when I is 0, I less than equals to n minus 2, I plus plus. As you said, 0 to n minus 2 is a trip loop. Within that there is a comparison. J is always one step ahead of I plus 1 to n minus 1. Now, if you come back to this particular shifting technique, before I say the program one more time, can I generalize these terms? A of 0 greater than A of 1, A of 0 greater than A of 2, A of 0 greater than A of 3. In this strip, which variable maintains a value as 0? Sure, I. So it means that I can summarize this A of 0 as A of I. Greater than 1, 2, 3, whose value are they? Don't you feel that is J? So I can say A of J. Again at this place, I is 1. Can I summarize this as A of I and this as A of J? And here again the same stuff, A of I greater than A of J. So it means that when trips and comparison are doing, we are just saying A of I greater than A of J, right? So let me use this particular code. See here, when I is 0, J starts with what? I plus 1. 12 greater than 7, 12 greater than 7, true, true in the sense, do this particular swapping operation. A of I goes to temp, A of G goes to A of I, and temp goes to A of J. So 7 comes at this place, 7 comes at this place, 12 comes to this place, 4 and 9. When you go back, which loop gets incremented? J. I is still at 0, J gets increased to next. 7 greater than 4, true, true in the sense, again swap these two, 4, 12, 7, 9. I is still 0, 4 greater than 9, false. False in the sense, keep the number as it is, don't do this particular operation. So J is increased, I is kept constant. So I is a trip and J is a comparison. Keep on doing this particular operation again and again. Once you end up with the last value, once you compare this numbers 4, 12, 7, 9, this is the end of the first strip. When you repeat this for all the times, automatically the numbers are arranged in ascending order. And finally, I'll display the numbers as the ascending order is for loop and then these numbers. So we are using these operations for ascending. If I ask you to modify this code for descending order, there will not be much change. What I need to do is, instead of asking question A of I greater than A of J, you should ask a question as A of I less than A of J. Automatically the entire program remains same, and then I can use this particular technique. So I can say, instead of ascending order, I should say descending order is, and then display this particular value. If I ask you to do a program ascending and descending both in one program, so never think of using a if else. Write the program of ascending order once. You can try descending order one more time, or you can display the array in a reverse order. First, a program for ascending order, display that. Ascending order is done, ascending order has been displayed. Just display the ascending array in reverse order. I have this particular ascending array called as 4, 7, 9, 12. If I display it in reverse order, 12, 9, 7, 4. Don't you feel that is descending order? I can try this without doing descending. try ascending order, display the numbers in reverse order. When I say display the numbers in reverse order, so here for I equals to n minus 1, I greater than equals 0, I minus minus. So here I am supposed to start from n minus 1, go towards 0, I minus minus 1, rest all instructions will be as it is, rest all program will be still as it is. That is how we carry out the sorting of arrays. I, j, I trip, j comparisons, a of I, a of j, I goes from 0 to n minus 2, j goes from I plus 1 to n minus 1. All in future programs when sorting is used will stick to this particular rule itself. Thank you.